Hello, in this video I'm going to demonstrate one of the functionalities within the SMARTree client, and that is digital image correlation. So digital image correlation allows you to extract deformation or strain information from a sequence of images where you would have motion or relative motion. And so it's a fairly common practice used by academia and industry to really track the motion or relative motion of a structure during a test. So you can use digital image correlation to look at classical tension tests. You can also use it to look at impact and whatever motion you would like to capture. You can use digital image correlation to pull out the deformation of the structure of the part with respect to its initial state or initial frame. So what I'm going to do here is kind of walk you through how that's done. So in order to do that, what I'm going to do is I'm going to import a sequence of images. So in order to do that, I'm going to go to the Files tab and click on this Files button. And I have a sequence of images right here. These images were recorded originally as a high-speed movie, then converted into a sequence of TiFF files. And in this particular instance, I'm looking at a side impact of a B-pillar. So we have a B-pillar here mounted on an impact frame. This is a side impact intrusion event. And what we're going to do is we're going to try and track the deformation of this structure. So in order to analyze these images, we first need to bring them into the main work area. So this is it over here. Here's our preview area, just allows us to see. But once we bring them over here, now they're in the work area, and you can click on the files here and you can see them down here. You can resize this, make it bigger if you like. So now the files are registered inside the software. So the next step is we're going to be opening one of the tools I mentioned. In this case, the tool is called DIC. So if you open up the DIC, that opens up this window. So in this window, we have a sequence of functions up here on top that you can edit. The left is a little tree showing X and Y, or a table showing X and Y positions. Once I start adding points to my image that I'd like to track, those will show up right here. So the first tab basically shows you your sequence, and you can use this little slider bar here to kind of walk you through the impact event in this case, and just to show that everything is there. The next step we're going to do is basically add our points and add a scale. So those are the two steps you need to do. So let's first add a scale. So a scale tells the software what is the pixel represent in terms of distance. So you need to know what you're looking at in terms of what is its spatial size. So by hitting the scale button, you can then pick 2 points, anywhere in the image. You can pick 2 points that you know of a certain distance. So it's always good in your test to have something of a known distance inside your field of view. So in this case, I know that these 2 points are 4 inches apart. And so you can specify, if your pixel scaling is different in X and Y, you can specify a distance in both X and Y. The pixels are square in this particular image, so I know that 4 inches represents this distance in both the X and Y direction. So now I'm done with my scale. The next step is to add the points themselves. So in order to add the points, you need to make sure this button keep is on. This clear button will empty the points if you want to start over. But in order for you to add points, you make sure this keep button is on. In this case, we're going to add individual points, but we could actually add a line. If you want to add a line of points, you can just add a line by just drawing a line like such. Or you can also add a grid, and a grid will draw a grid of, in this case, 13 by 13. So if I was to draw a grid in here, I could draw a grid like so, and it will track all those points, and here they are located right here. But in this case, I'm just going to add a couple of discrete points along the back spine of this B-pillar, and I want to track those points. So the keep button is on, and so now what I do is I can simply add those points. So I'm just going to click a few points along here, and you really want to be adding these points at an area of contrast. You don't want to be adding these points out here in the black area, because what's going to happen is the software will have a hard time finding the motion of those points. But if you have points that are clearly marked, and in this case I have a number of dots on the side of my B-pillar, and so that there's enough contrast with those dots that the software can now track them. So I've added a few points, in this case 7 points along the back, and I just want to track how they move. I have a scale, so now I know what the motion of those points are going to be. So in order to run the tracing algorithm, you just hit the track button, and what it'll do now is it's going to track those points through the entire load cycle, and it'll do its best job to try and keep an eye on them. So you can see one of the things that happens is those points do change color. The color change is a function of the amplitude. So the more the amplitude, the bigger the color change. and that's perfectly normal. Once the tracing is done, a little window pops up saying your trace is complete and you are now finished. So if you want to look at your data, you can just click on the data button, and this is the data from those points, so it's all right here. You can look at the relative position, so that's the full motion of those parts in X and Y. You can look at the absolute position of those points, like how did all of those points move from their zero state. And if you want to save the data, you can just hit the save button, and we can save it, and it saves it in an Excel format, Excel file. So we'll just call them DIC points .csv. So they're comma separated variables, and so now the data is saved. So if I want to look at that particular data, I can pull that up pretty quickly here. So what I'll do is I'll just open up that particular folder where that data was saved, and you can actually look at that file. And so it's loaded basically in here, and we have it under name. So we have a B-pillar crash test, and I believe this was impact A. And then in here we have our DIC points. So now I can load them up in Microsoft Excel, for instance, and you'll see right here, the first column will be the image that each one of those points was taken from. And the remaining columns are the X1 and Y1 values or displacements, essentially, or positions, I'm sorry, over the entire impact event, and you can track all of those. So you can plot those in Excel and create a report out of those without any issue. So that's basically the way that this digital image correlation environment works. You can save a report. Once you're done, you can close this window. You can actually save this as a SMARTree. You can add more information in here if you want to, and save that as a report as well. So if you want to learn more about the other features in SMARTree, you can go to the SMARTree YouTube site, and it'll show you all the other features that we have available as well. Thank you.